So I'm here off my bus stop at a place I frequent every single week, sometimes more often, Synology Hack Lab. This is a local makerspace, and they have a problem that I think a lot of small business and other organizations have, and that is they need a basic NAS. So they want to store files relating to the business, nonprofit, relating to the 3D printing, CNC machining they do there, that kind of stuff. Ideally, they want some remote access, but they don't want to pay a cloud provider like Google or Microsoft or something like that. They want something self-hosted. So today, I'm carrying with me a Ugreen NAS. So this is a Ugreen DXP 2800 GT. So the new GT has higher CPU performance than some of their older models, at least in the smaller form factors like this. This is only a 2 bay. And I think it's going to be perfect for the Hack Lab today. So if you want to see how I take this nice little Ugreen NAS and set up everything that a small business or a Hack Lab needs to operate, then come along on this adventure. So I got the box right here. Let's take a look at what's inside. So here we go with the 2 bay model. Looks like on the front we got a USB 3, it says 3.2, and a Type-C and a power button. Flipping it around to the back, we have USB 2, USB 3.2, 10 gig Ethernet, and HDMI. Before I set this guy up for the Hack Lab, I'm going to tear it down to show you guys all the hardware inside. So I guess time to break out the iFixit toolkit. Let's get on with it. So on the bottom of the unit, there's this little cover here. This, I believe, is where we get to the M.2s. I don't think this thing has accessible RAM. Let's see, that looks like a number 1 Phillips. Oh, that is in fact just the RAM. So it's got the little spring to push the door out, like the other Ugreen models have. I like that. Let me pop the RAM out, and let's see what we got in here. Like self-branded, there's a sort of thermal pad on it, so no markings on the RAM. I do like that they're doing 1 stick, even though it's only single channel, or I guess 2 half channels in DDR5. Some of their other models had 2 8 gig sticks, bringing it to 16 gig, which means if you want to upgrade it to 32 gig, you have to replace both sticks. But in this case, you only have to replace 1 stick if you're going to upgrade it, which I think for most of you that are running more applications that actually need the memory bandwidth, probably will be upgrading the quantity as well. Next, I'm going to pop the drive bays out. And the drive bays do have this little locking feature here, which is just a flathead screwdriver, but it's enough to keep kids from popping them out. And then, of course, these are toolless. I'll put drives in it when I actually populate it later, but this pops open, set the drive in, close it. So the mounting screws are just if you want to install a 2.5-inch drive, because these are toolless for 3.5. And it's nice to see toolless drive access, of course. Not everyone has it. Most people have it by this point. And really, it should be the standard for hard drive NASs like this. So with those taken out, we can take a look down in the NAS. And so we see the fan back there, the back plane, and it looks like the SSDs are on that side there. So I'm going to take it apart a little bit further, and let's see how we can get to them. So it looks like I'm going to need to pry off these little guys here. Not a big deal. I need a smaller tool, though. So from what I recall before, I essentially have to like punch the back out through the front. Ow. So I just reached in through a screwdriver and poked this guy out, and that popped off the back cover. So with back cover move, we can look in the end here. So we got a fan, and under the fan, looks like we got some screws holding it to the extrusion. I think if I pull those out, I might have to pull the fan out. These fan screws are all coated in rubber, by the way, all around, so that's vibration isolation and noise dampening for the fans, which is nice to see. Okay, so I took all the screws out on this plate here, and I think that gets me this PCI card. Yeah, so APS15 to SATA, so that's a version number. And so this is going to be 2-channel SATA controller. It looks like it's on a PCIe by 4 connector. So I'm not sure if this is actually PCIe by 4 if you want to reuse this for other things. But so now the question is, how do I get this out? So the M.2s are on that side. And the CPU is on the bottom, I think. If you can see the heatsink down in there. There's another tiny fan down there, which cools the CPU. But I am trying to figure out how this is attached. I gotta figure it out. It was not as hard as I thought. The whole thing goes out the front. I was trying to pull it out the back. So I guess I'll set this down. we go. So taking a look at the motherboard here, we have the one RAM stick. This sort of white area is the area you can see from the outside, so they sort of mark it. This is the spring that pushes the door open. Battery for the real-time clock, and VRM components here. So looking at it from the side, we have the CPU cooler. There's a tiny fan there. So the back fan will blow air through this whole area. This is a riser board for the two M.2s, and it looks like these guys are intended to be toolless. So it looks like you would do is you would take the drive out here, and you would get the M.2s in through the front access here. So it looks like one of the thermal pads kind of fell. So that's probably supposed to sit down in there. But so this will open up, and then you can snap your M.2 in a toolless way. Toolless M.2s are of course super cool to me. The tiny little screws are such a huge pain in the ass, so it's nice to see toolless M.2. And if I read the instructions, I probably would have known that already. So I'm not going to take it down any further than this because the chance of me finding chips I can identify is quite low. But we've also got a PCIe riser here. This looks like it's maybe a by 4 to come up to these guys. That would mean they're by 2 each, which is probably reasonable given the amount of CPU lanes we have. So one thing I haven't found yet is the boot drive. So on the older Ugreen models, there was a 128 gig NVMe drive, which was connected to like PCIe Gen 1 or something like that, or PCIe by 1 Gen 3, and that was the boot drive. And I don't see that here on any of these boards. So I'm wondering if it's booting from onboard flash or onboard NVMe. There are like single chip NVMe's of that capacity, so you could get a 128 gig PCI Express single chip, or it could be eMMC. And I guess we'll learn that when we boot it up. So I'm gonna put this thing back together and see if I can get in the BIOS. So here's my test setup. So I got HDMI and USB 3 connected, and they're going over to my Cytrans Kiwi, so I can look at the screen on my laptop. So Ugreen has put a lot of work into developing their operating system, and it can do a lot of things. So it can run Docker containers, virtual machines, all kinds of stuff like that. And so I'm going to use that for the Synology Hack Lab. And if you're like a small business and you just want basic storage and a couple of applications, this will absolutely do that for you with the operating system out of the box pretty easily. But if you follow my channel, you probably care a lot more about running your own Linux distributions or things like that. So I'm going to try that as well. So I'm going to try booting up into Ubuntu or whatever I've got on my drive here. I'm not sure. And let's see if we can get into the BIOS. So Control F2 gets you into the BIOS. I got it a real keyboard because doing function keys on my Mac is a little bit awkward. But yeah, so here we have system date time, which is correct, obviously. Our boot option is so hard disk MMC, so that's Debian. So it looks like they're using eMMC. We're going to try saying USB device first. Linux LTS. Yeah, that's Alpine. Okay. So I had no trouble booting into the BIOS, and now I'm running my own Alpine. So I'm going to take a look at the hardware while I'm in here, just so we can do a bit of LSPCI, LSCPU, see what we got. And then I'll go on to Ugreen's operating system. And now I can run the basics, so like LSCPU. So this is an AMD Ryzen embedded R2514. So this should be a 4-core, 8-thread. So we have 2 threads per core. So going with this Ryzen embedded, this gives us 4 cores, 8 threads. So that's a decent performance uplift from the lower end Intel CPUs that are in the 2 and the 4 bay non-GT version. So those guys I think have 4 E-cores and 1 P-core, so that'd be 6 threads. However, these are full-on AMD Zen cores, so AMD doesn't have a stripped-down core like the E-core. So we get 4 performance cores, essentially. As for PCI devices, so it looks like we have a Quantra AQC113. So this is the N-based T-NIC, so this would be the 10, 2.5, 5 gig. And it looks like we just have the platform SATA controller here, so we don't have any external SATA controllers. So that means that the daughter card that carries the SATA drives must be carrying SATA across the PCI Express connector, not PCI Express. However, I happen to know that in this family of AMD chips, some of the SATA lanes and some of the PCI lanes share the same SERDES, so the same pins on the chip. So that means that with different BIOS or different firmware, they could be using that same connector for PCI Express or for SATA, depending on the model. That doesn't mean that you can use it for PCI Express, but it means that they're not wiring it differently. Editing AppLard here for a little bit of a clarification, I guess. So taking a look at the processor here, this is 2514. It is on socket FP5. So if I look at this, this shows essentially the high-speed I/O of the FP5 socket, and therefore these Zen Plus Gen chips. So I think this is a Picasso generation chip. So we have the GFX and the GPP PCI Express, so 8 lanes of each, 16 total. We have some dedicated Type-C. This one can do alt mode and a whole bunch of other stuff. Some of these display engines get pumped into those USB-Cs. But you're probably concerned about is these PCI or SATA. So by using these lanes here, they can get the option of using either PCI Express Gen 3x1 or SATA on the same wire. And so Ugreen has mentioned that these two NASs both support U.2 on the first 2 drive slots, the only 2 drive slots, I guess, in the 2-bay model. And so they're probably using this functionality to use the same wiring to change between SATA and NVMe. Now, I'm not sure how much NVMe bandwidth we have because I don't actually have any U.2s to test with. But based on this data, I would guess that it's probably a by 1 or a by 2 connection. So probably not hella fast. Now, Ugreen has mentioned over here that the M.2 slots run at 16 gigatransfers per second. And so if we look back at this map, we're at PCIe Gen 3 across the whole chip. So that means we're running PCIe Gen 3, which is 8 gigatransfers per lane at 2 lanes. So 2 lanes per M.2, at least for the GT series. Now, this isn't as good as some of Ugreen's other NASs, especially I believe the 8-bay and definitely the all M.2 NAS can do Gen 4 SSDs, so really, really fast performance. But again, this is 1 or 2 10 gigabit Ethernet, and even with 20 gigabit Ethernet, two PCIe M.2s will still outrun 20 gigabit Ethernet. So with these guys at the 10 gig class NAS, that's a reasonable trade-off, I think. As for the disks, I got a bunch of loop devices. That's part of Ubuntu. SDA, that is my test setup. So then it looks like we have like a 64 gig eMMC, of which they're using for their operating system. It's like 48 gigs for the OS and some other small, probably redundant boot partitions. So given that the OS is probably not that changing, this seems like a very reasonable choice. All of your data obviously will be on the data drives. The OS isn't exactly part of that. If you're flashing your own operating system, just do be aware that the eMMC will have probably less life than an NVMe SSD, although compared to the NVMe SSDs in the non-GT models, they're probably not the highest quality NVMe, to be honest. So this is a very reasonable trade-off to me, 64 gig eMMC for the operating system. So with that out of the way, I guess it's time to install some drives. So I got these 2 terabyte Western Digital Red Plus NAS drives. They're only 2 terabytes because have you seen hard drive prices these days? Like, dear God. Also, the Hack Lab doesn't really need a ton of space. So they're mostly going to be sharing 3D models to the 3D printer. I guess time lapses from the 3D printer, but those aren't that big either. And that kind of stuff. So mostly it's going to be small data files, 3D models, etc. and not like massive video projects like stuff I work on. So we're going to do 2 terabytes in a mirror because that gives us redundancy. Don't forget to eat this, by the way. So this is, of course, entirely toolless. So we just push on the catch right here. That pops open. Now I can take my hard drive and set it inside. There are these nice rubber vibration isolators in here that will kind of stab the mounting holes in the drive. And I just close it, and that's it. So off camera, I did the really basic out-of-box setup, no drives installed. So I used the phone app to find it, provision it, set up a local user account. From there, I got the IP address, which I could type into my web browser. Also, you can configure it for MDNS, but the default name is like the model number and serial number. So I called it hacklabnas.local, so now I can find it more easily. And now that I did that, I'm logged in. All the account creation, by the way, is entirely local. Cloud stuff is entirely optional. You don't have to create a cloud account through the setup wizard to get this guy running. So now at this point, I brought the NAS over to the Hack Lab and got it set up. So I didn't record the entire setup process, although I probably should have because it was really easy. But I was in the lab and there was a lot of other things going on in our general meeting. So out of respect for all the members, I didn't want to record that whole thing. But here's what I got set up. So I'm here logged into the NAS, and I'm actually logged in remotely via the URL here, so synologyhacklab.ugreenlink. So I have an admin account I created for myself and some of the other admins. I also have a general user account that I gave to all of the Hack Lab members. It's on the Discord if you check there. And so they can log in remotely, upload, download files, stuff like that. And the intent of this NAS isn't to be any sort of private storage. It's to have files that we're trying to transfer around the different machines at the lab. So between the CNC, the computer that controls the CNC, the 3D printer. If you're dumping a file on the NAS, it's so that it can go to one of the machines and you can print it. So it's not necessarily private. For a business though, you'd obviously want to create more granular user permissions here. So I'll get into some of the ways we can link that a little bit later. But having an account for everyone and creating permissions properly is something you would definitely want to do if you weren't like a community organization like mine. So first things first, I came over to storage. It told me how to set it up. It had a little wizard in the bottom that told me everything I needed to do. And it was super easy. So I got two hard drives here. They're just called hard drive 1, hard drive 2. And they are connected as a Btrfs RAID 1. So I created a storage pool that's RAID 1. I have a volume that's Btrfs, and yeah. Now over on the hard drive side here, we can run hard drives tests, so it runs smart tests once a week, the rapid test and the full test once a month on these two hard drives. This was all by default. I didn't even have to configure this. And over in the notifications, it's actually telling me, that was when I first inserted it, but it's telling me somewhere here, yeah, so in the logs it just says resolved good. If there's an error, it'll send a higher level alert. So all of you guys saying how much better TrueNAS is, we can do smart tests here in UGREEN NAS, and you can't do them on TrueNAS. TrueNAS has ZFS though, and this doesn't. And of course, I can see all the data on the hard drive. So if I go into the details view, I can see the important data as well as the smart information, and they've given it nice names, but you can turn those off if you want. And I can also tell to alert on an increase in the bad sector count, so I'll get a notification. That can help you track drive wear out. So all of this was extremely easy to set up. We got this pool going in just a couple of minutes at the lab. Now it is a really simple pool, it's only a RAID 1, and we're not doing anything complicated in the configuration settings, but they do support RAID 5, RAID 6. I believe all of the RAID is via Linux MD80M and not via Btrfs. So Btrfs is the file system. It's running on top of Linux MD to do the RAID. So now going over here to files, I can look at my files, I guess. So somewhere here I made a shared folder that's called shared. And someone made a text file on it called hee, and it looks like we have some bamboo data. Yeah, so someone was doing a print, so that ended up in here. But this is all accessible directly through the web UI. I can download this file if I want to. I can upload more. I can actually open it and read it. What did they say? It just says first file. Haha. So of course, in addition to just web sharing, which I can do remotely, by the way, because I'm logged into the NAS remotely, I can also do this locally via Samba or via the web UI. So if you just go to hacklabnas.local, that's an MDNS name, everyone connected to the Wi-Fi in the Hack Lab can get to it. They know the username and password. It's shared in our members Discord. So they can log in, they can play with it, and they can drag and drop files from all the computers in the lab. So over here in Control Panel, we have plenty of useful features. So one thing I'm sure a lot of small business people will like is the domain LDAP. So we can come here and we can join a domain. I believe this is by a Samba support, but we're essentially, so if I click on Add here, so my options are Active Directory or LDAP, and I can join that server. I think I already mentioned I already set the .local name, so hacklabnas.local, so you're free to access that if you're on the same LAN. I also enabled remote access through Ugreen's cloud, and I can just name it whatever I want as long as the name's not taken. They also support DynDNS, so if you want to do port forwarding on your own, you can have it update DynDNS here as well. Now we also have the option of enabling Telnet, which is insecure, or SSH, which is preferred, and they will automatically turn it off after some amount of time to reduce the security risk of leaving it exposed. Now, of course, SSH with key-based authentication is very secure, so leaving it exposed is not a problem. But this is going to use the same username and password database as your users, and you're going to find people just absolutely hammering default usernames and passwords all day if you allow password auth. So next up, I asked some of the members what apps they wanted to run on the NAS, and they had a couple of good ideas. And the one thing they wanted was a security camera they could access remotely to see what's going on in the lab and just sort of watch the door. We have a lot of people coming and going, and we want to be able to see that kind of stuff. Someone had tried to set it up before, but as this is a volunteer organization, a lot of things were attempted and a lot of them failed. They were trying to run software on one of the desktops. As soon as you turn the desktop off, it fell over, etc. So, security camera. Second, we have a Bambu Labs 3D printer, and we want to locally control it because we don't trust Bambu's cloud. So we wanted BamBuddy, and that's, again, a basic Linux app. We just need a place to run it. So over here, you can go to the App Center. We can see what apps we could choose from Ugreen's set. So they actually have quite a lot of their own apps here. And so you can install Home Assistant directly, for example. But I chose to install Docker and also Virtual Machine, and also Surveillance Center. So we have those three things kind of chilling. We also have sync and backup photos, music, etc. So these are kind of things that most small business apps or home apps would probably like. So on the virtual machine side, we have the option of running full virtual machines. So I could say I'm going to store them in volume 1, and then we could see, looks like I can import an image, VMDK, etc. Or I could create manually. I don't actually have any images, so I'm not going to walk through that process right now. I actually ended up using Docker. I think you guys know my feelings on Docker. And I did have a little bit of a struggle here because one of the pieces of software I wanted to run didn't have an official Docker file. So that means now I'm trusting someone else to build an image of a software that I could have just pulled directly if I wasn't using Docker. Another option, I guess, is to run an Alpine and then install it in there manually. But Docker is an option that's provided on here, and if you want to run basic container stacks, it works really well. So here I created a project. They call it a project, so it's essentially when you have a set of containers running. So one of them is the camera, and one of them is the BamBuddy. Looks like I could update BamBuddy, interesting. And so the way this works is basically if I go in here, you paste in your Docker compose config, just copy and paste it right in here. So this is running BamBuddy, and I can set up what I want to run here. So copy and paste in the Docker compose, and the Ugreen OS will run that stack as your project pretty autonomously. So here I can see how much this is using hardly any CPU. Are we generating many logs? Not really. And the one container is running. We can update though. Let's update it. Well, that updates. I'll show you guys what I did for the camera. So for the security camera, I'm running Ugreen's built-in surveillance center. It's pretty basic. I guess I'll show you that first. So it's going to give me a warning that we're accessing the video remotely. Video stream is encrypted in transmission, not stored on the cloud. They may charge for this in the future, it says. So we'll just say okay. And then, of course, that's the inside of the hack lab. So there's the emergency exit sign over the door. Yeah, the bandwidth is not the best here, but that's clearly working. One downside I had is that the location, they just have like a pre-made list. So I guess I named it the living room. So because the surveillance center only supports ONVIF or RTP cameras, I had to do something to proxy the USB webcam we're using for this. This is not a real security camera. So I'm running a Docker container for that as well, and I passed in the video for Linux device. So I come back over to Docker, I create a project for the camera, and it's running go to RTC. So this is a RTC restreamer. So the configuration I generated, so we're running go to RTC in privileged mode, and we're passing in the dev video and the volume config. So then I went over here into the Docker folder and the camera project, and I had some trouble getting the go to rtc.yaml to create. I kept creating it as a directory instead of a file, so I eventually just mapped in the whole directory. But here is the YAML file. So we're just listening on port 1984 for the web UI, which we don't really need anyway. And then we're connecting to this video for Linux camera at dev video 0, input form at H.264, and we're just restreaming that H.264 directly. And we can see we're using essentially no CPU, also essentially no RAM, because we're just restreaming the camera directly. And so that gets us to this nice image of the living room, I guess. So this video is not exactly about BamBuddy, but BamBuddy is just a web app that lets you manage a fleet of Bambu printers using local connect mode, because Bambu are being dicks about their cloud service and forcing cloud access, etc. So because we've had a Bambu printer for a number of years, we wanted to manage that. Unfortunately, I don't have that access via the remote connection. The remote connection only gives me access to the UI of the NAS. So it's running on a different port. And so if you're in the lab, you can do hacklab NAS like 8080 or something like that. 8000, I don't remember the exact one. And that gets you BamBuddy. We can also drop files into the file folder for it to find, stuff like that. That's all integrated. And so that's just one of the many apps you can run on this NAS. And so this NAS, the GT series, has a higher end processor than the original 2800 and 4800 NASs. So we have an AMD 4-core 8-thread Zen processor. It's a pretty good processor, especially compared to the lower end embedded ones from Intel that were in the non-GT version of the smaller NASs. Now the higher end UGREEN NASs, the 6-bay, 8-bay, and especially the all SSD NAS already had pretty high-end CPUs to begin with before, but the GT series gives a performance boost without a drive capacity boost to the smaller NASs. So I think that's perfect for an application like the Hack Lab here. We don't need a ton of storage. We don't honestly need a ton of compute either, but we have applications like BAMBuddy and some other things. We might be running some like AI-based detection of like print failures, that kind of stuff. We have access to the Bamboo camera in BAMBuddy, so we can do print failure detection by monitoring the camera and seeing if things turn into a disaster. And that could use some performance. If we wanted to do like local image recognition or stuff like that, we have the Vega graphics processor on the AMD chip that we can work with as well in containers. So that's nice. Now, I'd like to thank Ugreen for sending this NAS over to HackLab Sanyoki RY. They're a nonprofit in the Sanyoki area. If you're in Sanyoki or Southern Ostrobothnia in general, feel free to join HackLab Sanyoki. We're in the old train station. You probably know where that is if you live here. We have a number of different really cool machines. So we have the Carvera Air that I've made a video about before. We have the Bamboo 3D printer, and we have a number of other tools you can obviously use if you're a member. So if you're just sort of interested in it, we have meetings every Thursday at 6-ish, 15-ish, 6:30-ish, something like that in the evening. So we have the doors open for anyone. If you want to follow me, Appleard, I have a Discord server, link down below for that. I also make my own t-shirts. If you want to support my channel, buying my merch is a great way to do that. This is not one of my t-shirts. This is the famous Dymaxion House from Buckminster Fuller, but I have my own t-shirts, link down below for my Ko-fi where you can buy those. I also am on Mastodon, which is kind of like the Dead Bird site, but a Mastodon instead of a bird. And I guess I'll see you guys on the next adventure.